Today's lesson is about ratios and proportions. Our objective is to write ratios and solve proportions. Our essential understanding is that you can write a ratio to compare two quantities. So the simple explanation, a ratio is just a fraction. A proportion is just a fraction equal to a fraction. So you should all know what a fraction is, so we can have 3/4. And a proportion is a fraction equal to a fraction, which means they have to be equal to each other. So a half is equal to 5/10. So that could be a proportion. There's three ways you can write a ratio. You can write it as a fraction, you can write it with semicolons, or you can write it saying A to B. So we're going to do this first example, deal with ratios. Okay, table at the right gives us a baseball team's records over certain years. I want to know which year did the team have the best record? Well, the best record will be the ratio that's highest when you compare wins to losses. So I want to compare wins to losses. So whatever ratio is greatest, because that means they're going to win more games than they lose, will be the year in which the team had the best record. So for 1890, so 1890, if I compare 60 wins to 24 losses, 60 wins to 24 losses, and I reduce this, so I do 60 over 24, reduce it to the simplest form, and I get 5/2, which is 2.5. So that means for every 5 wins, they only have 2 losses. So that can also be pretty good, but we have to compare the other win-loss ratios. So I have 110, this is 1930, compared to 44. If I do 110 over 44, I also get 5/2, which is 2.5. 1970, I have 110 over 52. So if I reduce 110 over 52, I get 55/26, which is 2.1153. And then the last one is 2010. Compare 108 over 54. So 108 over 54 is just 2 over 1, which is 2. So out of all these ratios, which one has the highest win to loss ratio? Well, the one with the highest win to loss ratio is a tie. So it's a tie between 1890 and 1930 because they have the highest win-loss ratio, meaning that they win more games than they lost. Therefore, they're going to have the best record. Let's do a application problem with ratios. Okay, you have a bonsai tree and a cypress tree. I have a picture of a bonsai tree. I don't have the picture of the cypress tree from Florida. It's called the Senator. It's 118 feet tall. What's the ratio of the height of the bonsai to the height of the Senator? So I want the bonsai height compared to the height of the Senator. So there's my fraction. There's my ratio. I want to compare the ratio of the bonsai to the Senator. So in my question, I know that bonsai comes first, therefore it's the numerator. Senator comes second, therefore it's the denominator. Don't forget, when you're working with ratios, you have to have the same units. So I know the bonsai is 15 inches. The Senator is 118 feet. I can't compare this because I'm in different units. So what I'm going to have to do is I'm going to convert the 118 feet to inches by multiplying by 12. So I do 118 times 12. The reason why I'm doing that is I want to convert feet to inches. There's 12 inches in a foot. By 118 feet, I do 12 times 118, and I get 1416. So I have 15 over 1416. And again, this is inches over inches. Now I can reduce. I have 15 over 1416. This reduces to 5 over 472. And that's my ratio of the bonsai compared to the senator. Notice that there is no more units, okay? There's no units in a ratio here. Why? Because inches over inches cancels out, and you're left with just 5 over 472, and you reduce the fraction of 15 over 1416. So let's go to the next example. Let's do a ratio when you're comparing members of a school band that are buying pots of tulips and pots of daffodils to sell for their fundraiser. They're going to buy 120 pots of flowers total, and the ratio is number of tulips divided by the number of daffodils, or the ratio of tulips to daffodils has to be in a ratio of 2 to 3. How many pots of each type of flower should they buy? So I know that the tulip pots plus the daffodil pots has to equal 120 pots. But I know the ratio is in the form of 2 to 3. That means for every 2 tulips, they have to buy 3 daffodils. So my equation to solve this is 2x plus 3x equals 120. Because this represents the 2x is the tulips, the 3x is the daffodils. Because if I buy one of each, okay, one quantity of each, I'm still in the ratio of 2 to 3. So to solve this, I have 5x equals 120 divided by 5 divided by 5. So if I do 120 divided by 5, I get x is equal to 24. So if x is equal to 24, I do 2 times 24, which equals, and this is our tulips, 2 times 24 is 48. And the daffodils will equal 3 times 24. So 3 times 24, which gives us 72. And you should also that 48 plus 72 is 120. And you should also notice that 48 over 72 reduces to 2/3. So when you're given these types of problems, when you're given a quantity that's in a ratio, the simplest way to approach these types of problems, if you see it on a standardized test, is to take your numerator, slap an x next to it, add it to the denominator, put an x to it, and set it equal to the total number that you're trying to find. 95% of the chance it's going to work like that. And here's another example. So I have 2 supplementary angles. So supplementary angles are equal to 180. They're in the ratio of 1 to 4. What's the measures of the angles? Well, one angle is 4 times bigger than the other. So 1x plus 4x equals 180. So I have 5x equals 180. So I have 180 divided by 5, and I have 36. Because the ratio of 1 to 4 is also 1 over 4. So I have one angle, which is 36, and another angle that's 144. And those are the measures of the angles. You can also do this with extended ratios, where you have A to B, B to C, therefore A gets ratioed to C. It's like the transitive property. If A is equal to B and B is equal to C, therefore A is equal to C. So same thing, extended ratios. You can have this, you can have a half equal to 2/4, which is equal to 10/20. That's an extended ratio when you're comparing, or not really comparing, when you have three ratios equal to each other. They're all the same. So using extended ratios, I have a perimeter. Perimeter is the distance around an object. So you should know that this is perimeter is distance around the shape or the polygon. So the ratio is 3 to 5, 5 to 6, and I know the perimeter is 98. So this is 3x, 5x, and 6x, and I know that 3x plus 5x plus 6x in the extended ratio is all equal to 98 because that's my perimeter. So I have 3x, 5x is 8x, 8x and 6x is 14x equals 98 divided by 14. So 98 divided by 14 is 7. So x is equal to 7. So my lengths, again, I have to substitute it back in. 3 times 7, 21. I have 5 times 7, 35. And I have 6 times 7, which is 42. And you should notice that 42 plus 21 plus 35, that all equals 98. So I found my side lengths using extended ratios and using those extended ratios and setting it into a algebraic equation. So in this part, you can also have two ratios are equivalent. So if you have two fractions that are equivalent, that means it's a proportion. And the cross products of the proportions are always going to be equal. When you have proportions, you also have extremes and means. So the extremes are on the outer, the means are on the inner. So again, proportions, two fractions equal to each other. So if you have A over B equals C over D, it also means that A times D is the same as B times C because of the cross product. Okay. Here's another example. If you have 1 over 2 equals 10 over 20, well, yeah, you know a half equals the same as 10 over 20, but if you use your cross product rules, 2 times 10 has to equal 1 times 20. Is this true? Yeah, 2 times 10 is 20. 1 times 20 is 20. So the cross products of the proportions are equal, therefore the fractions are equal. So in a proportion, the product of the extremes is equal to the product of the means, and I just explained that up top. Product again means multiplication. So if you have a proportion, each problem is solved by doing the cross products. So it's a proportion. So how do I solve it? I could do 6 times 4 equals 5x. I have 24 equals 5x divided by 5, and therefore x is equal to 24 over 5. Same thing here. I have a fraction equal to a fraction. How do I solve? Doing the cross product. So it's 3 times y plus 4 equals 9y. Distribute 3y plus 12 equals 9y. Now it's your algebra. Solve minus 3y. And I have 12 equals 6y. Y is equal to 2. And we can easily see that if I substitute 2 in here, if I have y, not y, if I do 2 plus 4 over 9 is 6 over 9, which reduces to 2/3. And if y is 2, this is 2/3, and I notice that they're the same. So when you're solving for proportions, you can easily check by substituting back in. So let's substitute back in here. If I have 6 over 24 over 5 equal to 5 over 4, I can reduce this. So this is 30 over 24 equals 5 over 4, and 30 over 24 is indeed 5 over 4. So that's true. You also have some properties of proportions where A, B, C, and D do not equal 0. So if you have a proportion, A over B equals C over D, and this is going to be equivalent to B over A equals D over C. I like to call this property the flip property. Basically, if you do the reciprocals, they're also going to be equal. The second property with proportions is if you have A over B equals C over D, you can switch the means. So I call this the switch property. So you have a switch property with proportions, you have a switch property of proportions, and then the last property, if you have a proportion A over B equals C over D, it's the same as A plus B over B, C plus D over D. So this is basically add the denominator to numerator. So you have the flip property, the switch property, and the add property. So let's apply these properties to a couple problems. You have in the diagram, you have x over 6 is equal to y over 7. What completes the equivalent proportion x over y, blank over blank? Justify your answer. So I'm given x over 6, y over 7. And have a proportion that is going to be equivalent. So I want to fill in these blocks. So these proportions are going to be the same. They don't look the same, but you have to remember that the product of the means are equal to the product of the extremes. So if I do that property, if I do the cross products, I know that 7x has to equal 6y. So I know down here, I know that since these proportions are the same, I know that when I do the cross products, I still have to end up with 7x equals 6y. Well, that means when I do the cross products, 6 goes here and 7 goes here. Because when I do the cross products, I get 7x equals 6y, which is what I needed from the given proportion. The diagram doesn't even really need to be in this problem, but we will get to that later on in a couple lessons. So again, the key to solving missing proportions is look at the given proportion, do your cross products. That will tell you what your missing blanks have to be. And how do we justify our answer? Well, what did we do? We switched, okay? We did the switch property. And that's our reasoning. So let's do part A. Okay. Well, I'm given x over 6 equals y over 7. That means my cross product is 7x equals 6y. So for part A, I have 6 over x equals blank over blank. And again, these have to be the same. That means when I do the cross products, I still have to end up with 7x equals 6y. Well, 7 goes up top, y goes down below. Because when I do the cross products, I get 7x equals 6y. And they're the same. Apply the same concept to B. So I have y plus 7 over 7. So in this case, when I do the cross products, I still have to end up with 7x 7x plus, or 7x equals 6y. So this is x plus 6 over 6. Well, some of you might not understand, how are these two equivalent? Okay, well, let's do the cross product. I have 7 times x plus 6 equals 6, y plus 7. How are these two going to end up to 7x, 6y? Well, distribute 7x plus 42 equals 6y equals, or sorry, 6y plus 42. I can subtract 42 from both sides, and I have 7x equals 6y because the 42's are now going to have no effect on the equation. So they're the same. So part A was your flip property, and this was your add property. And that concludes the lesson for ratios and proportions. You just got to remember that ratios are fractions. You got to have the same units to work with ratios. Proportions, fraction equal to a fraction, again, have to have same units. And don't forget with proportions that when you cross multiply, they have to be equivalent or the same. If you have any questions, email me, see me in class, and we will do some practice problems.